Roslyn Hill Mining owns 100% of the Paru Station lead mine, located 30 kilometres from Wiluna and 900 kilometres northwest of Perth in Western Australia. The mine, currently on care and maintenance, has been one of the world's most significant lead producers, with over 300 kilotons of lead carbonate concentrate being exported to overseas smelters since its commissioning in the mid-2000s. The existing mine covers 450 hectares and consists of shallow open-cut pits, a 1.7 million tonne per annum primary crusher, mill and flotation plant, management offices and a village with accommodation and facilities for 170 employees. The lead deposits at Paru Station were formed around 1.5 billion years ago. Erosion brought the buried deposits closer to the surface. Over time, weathering converted the original sulfide mineralisation into a mixture of oxidised lead minerals such as cerussite and anglesite. Lead was previously transported from the mine in concentrate, progressing through a very intensive process of handling, packing and environmental controls before transportation to port. Roslyn Hill Mining is now seeking to expand the operation to integrate a first-of-its-kind state-of-the-art downstream hydrometallurgical processing facility for the unique qualities of the Paru Station lead concentrates. The facility will utilise an innovative new hydrometallurgical technology using methane sulfonic acid to leach lead from lead concentrates and electrowinning to produce lead metal. Whilst acid leaching and electrowinning are well-known mineral processing unit operations, the use of methane sulfonic acid in these conditions will be an industry first. The mine will produce a high-quality 4/9 finished lead product on-site and export as direct feed for global battery manufacturers without further processing. The technology has been pioneered by Dr. David Dreisinger, Professor at the University of British Columbia, Vancouver, in the field of hydrometallurgy, Industrial Research Chair in Hydrometallurgy, and a company director.
In 2010, I was approached by the large chemical manufacturer BASF from Germany to explore the commercial use of its methane sulfonic acid production, or MSA as it's known in the mining industry. MSA is an interesting chemical. It has low toxicity, it's odorous, it's chemically stable, it's non-oxidizing, has a low corrosivity, and it's fairly easy to handle. It turns out that lead is highly soluble in methane sulfonic acid, even at ambient conditions. Basically 143 grams of lead for every 100 grams of MSA at 23 degrees Celsius. Because the lead mineralization at Paru Station is a mixed oxide type of mineralization, which is composed principally of cerussite, which is lead carbonate, and to a lesser extent anglesite, which is lead sulfate, I consider that MSA could be used as leaching agent for these minerals to produce lead metal at the mine site through a hydrometallurgical process. By producing finished product on site, the mine could avoid environmentally hazardous and costly transport of the lead carbonate concentrates, and also the expensive and difficult smelting overseas. Over a number of years, I oversaw test work at the University of British Columbia and developed basically a hydrometallurgical mixed oxide and also a lead sulfide technology using MSA, both of which Lead Effects now own the exclusive global license to.
Under David's guidance, a hydrometallurgical process has now been developed and thoroughly tested through a full-cycle demonstration plant in collaboration with ALS Metallurgy in Perth, WA. 4 types of ore samples from the mine have been processed through the demonstration plant, producing approximately 1 tonne of lead cathode at an overall recovery of 82 to 85%. The process commences with crushing and grinding of ore in a ball mill and passing through a dual screening process. The fine lead ore is then fed as a wet slurry through 4 stages of conditioning using sulfuric acid, lime, sodium hydrosulfide, and finally a flotation collector. A rougher concentrate is separated off and moves on to a flotation column, where the suspended lead minerals attach to air bubbles and are floated to the surface as they rise up the column, emerging as a final concentrate at 72% lead grade. The dried concentrate is then resuspended in an electrolyte solution ready for leaching. The solution then passes through 6 leach tanks that use MSA to dissolve 90% of the lead into a new lead MSA solution. Next, the leached lead solution is pumped to the electrowinning circuit within the tank house. Electrolysis draws the lead out of the liquid and is deposited on the lead starter plates, known as cathodes. The lead cathodes are washed and then melted in an induction furnace in a fully automated lead ingot casting area. The remaining 10% lead sulfate minerals are recirculated to recover the contained lead. Environmental approvals to build the hydrometallurgical facility and expand the mining operations at Paru Station have been granted by the Western Australian State Government. With over 1.5 million tonnes of known mineral resources defined, there is sufficient mineral endowment to host a 15 to 20-year mine life. At steady production, the mine will produce approximately 70,000 tonnes per annum of 4/9 lead ingot at a cost of approximately $1,350 per tonne. The capital cost of the hydrometallurgical facility is estimated at $150 million and will create 230 full-time jobs in operations, plus business and employment opportunities in the local community.
The hydrometallurgical technology to be implemented at Paru Station is an example of how research and development and innovation can be applied to deliver both positive environmental impacts and long-term sustainable benefits to stakeholders through continued operations. Subject to financing in early 2019, we expect to be a long-term, reliable producer of high-quality lead ingots to the world's battery industry from the second half of 2020. Once again, Roslyn Hill Mining is set to become one of the world's top 10 lead producers.